fact, the first community public viewing of technology that was developed by Dr. Milos Popovic and his team here at Toronto Rehab. We're doing a live demonstration of functional electrical stimulation with Dr. Howard Rocket, who is currently in a clinical trial, and we have physiotherapists and occupational therapists extraordinaire in Irene Tunis and Debbie Hubert. So they're going to be actually doing the demonstration a little bit later. So let me introduce Dr. Popovic. Milos, Dr. Popovic, is Director of Toronto Rehab's Rehabilitation Engineering Laboratory. Yes, we do engineering here at Toronto Rehab, which is a little unique. It distinguishes us for sure, and Milos is one of our stars. He is the holder of the Toronto Rehabilitation Institute Chair in Spinal Cord Injury Research. He's a biomedical engineer, Toronto Rehab Senior Scientist, and Associate Professor with the Institute of Biomaterials and Biomedical Engineering at the University of Toronto. He has built a team that is helping to transform spinal cord and stroke treatments. He has always been involved in the fields of power systems, robotics, and aerospace engineering. It is helping people paralyzed by spinal cord injury and stroke regain their ability to move. He has captured people's imagination. He's captured certainly the foundation's imagination, and we are extraordinarily lucky to have him. His research lab is located at Toronto Rehab's Lyndhurst Centre. So Toronto Rehab is a network of hospitals itself. We have the largest spinal cord rehabilitation hospital in Canada and the third largest in the world, located in and around Bayview and Eglinton. We call it Lyndhurst. It's home to patients, to scientists, to clinicians, and students. And they study patients and they develop these treatments. Treatments that truly transform lives. Tonight, Milos will discuss his work with FES, functional electrical stimulation, FES for short. For the first time, patients with paralysis can now have treatment aimed at restoring function. The Neural Engineering and Therapeutics team has been able to produce unprecedented levels of recovery. It is the first therapy to clinically report significant increases in upper arm mobility in severe stroke patients and spinal cord injury patients. The device reinvigorates intact parts of the central nervous system and muscles. It was recently approved by Health Canada, and it will be soon launched nationwide. It has been commercialized. It's out there. An organization called MindMove actually has the product and is, Mindtech is moving it across Toronto, around the province, and like I said, across the nation. So on that note, and also a long intro, you're an extraordinary guy, so please welcome me.
Thank you, Sarah. This is long and unnecessary. So now you know who I am. So I'm delighted to be here today, and I want to show you a little bit of the technology, what it does, and then I'll also show you a little bit of the journey that we went through. This is overnight success of Diana Cass's, which took about 17 years. So I want to show you how that looks. So I am conflicted all around. I started this company, which is called Mindtech. And I'm shareholder in the company, and I will show you actually some of the technology that the company is commercializing, and I hope you will enjoy it. And I think this confliction situation is actually not a bad thing, because I think fundamental thing is we want to create something that will help our patients, and the way to do it is create a technology, get it out, and then through those successes, bring those successes back and circulate again and again, and hope to do many more of these successes. So, what is the motivation for this in the first place? I'll talk about stroke primarily today. This is one of our first patients. This video is almost 10 years old. And the purpose of this video is just to show you how a stroke patient who has a severe upper limb disability looks about 4 or 5 weeks after stroke. So Jennifer is just lifting his arm, but actually he has no function in that arm. He has no function in the shoulder, in the elbow, and that's what Jennifer is trying to show you. Even if you ask him to lift the arm, or extend the fingers, or extend the elbow, or wrist, flex splice or extend the wrist. The patient is not able to do it. That all hardware that he has on his arm is just to keep his fingers stretched and also to protect his arm from an injury. If I was smarter at that time, I would take this all off and film it without it, but I was not that smart. So anyway, you get an idea. This is so he has a little bit of finger flexion. Now, that may fool you because at this point in time he could flex the fingers, but about 10 days after that, his finger flexors become so tense that actually he can't even flex them anymore. They're always in the flex position. So that ability to move a little bit is actually gone very soon for various reasons. Then we can explain this later. So one thing which is important, the number of patients that this effect is huge. So in Europe, in the United States, we're looking almost at 1.9 million people. And some of them are very lucky, they recover, about 10% of them recover completely very soon after stroke, and some of them are really not so lucky and they die shortly after stroke. For those who survive the event, majority of them have different levels of impairment. And as you can see, many of them have, all of them have impairment in the upper limb. This is the group which has cognitive impairment, and with them it's more difficult to work with because they don't always understand what you're trying to achieve with them. But this is a very large number of people who have mildly or severely disabled upper limb. So it's almost 800,000 people or more who have this situation. Now, what is relevant with that is that once you are not able to use one of your arms, you depend on others and activities of daily living. And if you want to try this and figure out how that looks like, haven't had personal experience, the best thing is just put your hand in the pocket and try to do something for a couple of hours during the day. You will understand very soon how difficult and challenging that is. So, because of the challenges that this presents, we have burden of caring for these patients, and patients experience the burden, families, and of course all other people who are involved in the process, which is healthcare system, government, and others. And these are the real numbers which tell you about how much that costs the system, and these are the numbers that we can actually collect, right? But there's also hidden costs that we sometimes don't see, and the family loss of the job of the family member who is trying to help his family member who had a stroke. And so these costs are not all the costs that we see. And by the way, stroke is the leading cause of adult long-term disability anywhere in our country and anywhere in the world. So in about 70s or 80s, not necessarily for stroke patient populations, there was a suggestion which came out from engineers to design this device which is called neuroprosthesis for grasping. I'll try to explain to you very briefly how it works. What this technology essentially does is it provides very low energy currents to the nerves of the patient. That triggers all kinds of cascade of reactions, opens and closes different gates. I don't want to go through that. But essentially what it does is it creates the command, which normally goes through the axons, and goes right to the muscle to cause a muscle contraction. And usually stroke patients don't walk like that. Some do, but not all of them. But this is essentially what happens, right? You get a muscle contraction. Now, in this particular case, it's not very specific, but if you properly time firing of different muscles in the forearm, you can get different things like hand opening, hand closure, different gasping postures, and different reaching postures as well. This is a very good example. This is a spinal cord injury patient, which I want to show you. And just to set up this video, he essentially has neuroprosthesis placed on his arm. And we asked him to manipulate a particular object. This is a toothpaste, and he has to pick it up at the back and lift it. And he will try different tricks, which is called paralysis grasp. And you will see he's not able to do that. And then he uses electrical stimulation to pick the object. So this is when we were designing technology. This video is about 17 years old, plus minus a year or two. So this is when we were trying to figure out how to build this technology, how to create different grasping styles, and how to use them in activities of the day. As we were doing this with various patients, with a very clear idea that this is going to be an orthosis, which means they're going to build the technology, engineers. Engineers build the toys, and then they give it to other people and they should use it, right? So the idea was to build this neuroprosthesis, to put them on a patient, and they will use it all the time. That is, they're going to grasp and manipulate. And the reason why we did that is because everybody was doing that in the field. That was the mantra at the time. We're going to build this neuroprosthesis. They're going to be either implanted like this, or they're going to be on the surface of the body of the patient, and patients are going to use it every day to take the object. And as we were designing our technology, and we worked with our patients day in and out, thanks to our physiotherapists, occupational therapists who helped us in the process. We put a lot of hours with our patients. And as we were putting these hours with patients, we start realizing that many of them start recovering the voluntary hand function. That was 99, 98. And when we start getting these first results, neuroplasticity was not really in the news. And you talk to your neurologist that the patients are changing and they're getting hand function back. They were looking kind of funny at you. Just spontaneous recovery and things like that. So after we had a few of those spontaneous recoveries, right? We came and said, maybe we should use this as a therapy. And the way how we're going to use it is going to design very sophisticated neuroprosthesis, which you can do different grasping styles, reaching styles. And we'll do as much as we can with our patients, with the help of our occupational therapist, and see how far we can take the patients in their own recovery. So this is how the technology essentially works. You get a patient who is not able to open the hand or perform a grasp. You ask the patient to try to do the task on his own. And then, as the patient is struggling to do that, you fire all the muscles responsible for opening the hand and consecutively for closing the hand and picking up the object. So each phase of the movement is actually thought by the patient, planned by the patient, and tried to execute by the patient. The patient can't do it at the beginning, and it's substituted with electrical stimulation, and done exactly the way or similar way as the brain would normally do. So why this actually works? So here's a little bit of schematics, which was done by our student Catherine Alto, which is very nice. So I want to show you that. So here's essentially a patient has a stroke. He can plan the movement, but he cannot execute it because that part of the motor cortex responsible for performing the task is not there anymore. So what we do is we then apply electrical stimulation. Then the patient, we don't turn it on. We just put in the right muscles that we want to fire. Not on single one, multiple ones, but we use one here as an example. So to explain the Bristol. So the patient will kind of imagine the movement he wants to perform. He will struggle to do that. And of course, there's no pathway that he can push this through. And then we apply electrical stimulation. We get the movement. And then all the proprioceptive feedback goes back to the central nervous system and informs the brain that this has been done. Now, the good news, brain is a distributed system. So part of the, for example, left hemisphere is responsible 85% for control of the right hand. But it's also ipsilateral side, so the right hemisphere for 50% is responsible also for control of the right hand. So by providing this feedback, you're actually shifting the center of gravity of the control from the left side to the right side of the brain. And over time, you create a new connection, which enables patients to do this. So what is very important is this is not a technology. I mean, technology is really nice and sexy, but that's not the key thing. The key thing is that it's a combination of three elements. You have a patient who is engaged, motivated, understands what's going on, and is trying to do the right thing. At the same time, you have a therapist who is guiding the patient through the process, chooses which task the patient should do. They have to be meaningful tasks for the patient, and the patient is motivated to do it. And then you have an electrical stimulation which fires all the muscles in the proper time to coordinate that desire of the patient to perform the task, in the right moment firing the muscles, allowing that to happen. So that three elements, you cannot do with all these three elements in place. That's very critical. So what do we know? What do we do first? We actually do first reaching, because there's no point in you being able to open and close the hand if you cannot put the hand in the space and pick up some of the others. So we spend quite a good amount of time on reaching tasks, and then when the person learns how to reach objects, then we go into hand opening, closing, and picking up the object. These are different placement of the electrodes. We have multiple electrodes firing at the same time or a coordinated manner. This is just to show you how that would look like. And it's also helping therapists to know which muscles we are trying to target. So these are different locations. And so here's, for example, reaching forward and finger extension type of class. This is a pinch grasp. This is a lumbrical grasp, which is like that. This is a key grasp. And you can also do things like bilateral manipulation, very important for spinal cord injury patients because they have both hands. Right? So we'll pick up object with the left hand, bring it to the right hand, pick up the right hand, release it to the left, move it to the left. The device that we have developed, designed all this principle is called MindMove. It's done by the company MindTech here in Toronto and in Mississauga actually. And it's all the parts, all the components, all the brains inside is done with block. So it has about 70 protocols for stroke patients and 13 protocols for spinal cord injury patients. They are slightly different because pathologies are different. And in stroke patients, the difficult thing is to open a can. In spinal cord injury patients, it's difficult to close it. So there are different foci of the technology. So this is one patient which is trying to reach and open a can and pick an object. She was about 2 years after a stroke. When she came, she had no function in the hand. Actually, her hand was like that when she came. And she participated in intensive therapy study, which we published actually last year, and has a lot of traction. It's published in 2013, so already 10 plus citations. And the reason is because she was chronic. In chronic stroke patients, you don't expect them to improve. And then we ran her through this therapy. At the end, she was able to draw, pick small objects. And she didn't have to take the toxin, all these things can hang properly, which would jack it up. So that was a very nice thing. And most of the work with her has been done by Nori. Anyway, so I want to show you one of the randomized control trials that we have done in this patient population. So the methods are the following. We had patients divided into two groups. One was the control group, which got the best occupational therapy that we can offer. That was Debbie Steen, that did a fantastic job. And then we compared them against the group which received occupational therapy, conventional combined with functional stimulation. They received about 40 sessions, and each session lasted about an hour. In that hour, there was a putting on and taking off the system, which took 10 to 15 minutes, and the remaining 45 minutes was active work with the patient. The patients were, what you call it, as you can see, they were actually quite severely impaired in upper limb. So the Schreber master stage is low recovery less than 2. You've seen a patient at the beginning 1 or 2. Or for those who are familiar with this Fugl-Meyer upper extremity test, less than 15. What we normally do is when a patient has this type of disability or this type of impairment in upper limb, we usually try to teach the patient compensatory tasks. Am I correct? Or I'm cheating the audience? Okay. And then the very important thing is we didn't train the patients against the tests, because you can train the patient against the test. They learn how to do the test, but they're really bad at activity disability. We train them against activity disability and then use the test to find out how to do it. Okay, so here's exactly what happened in the study. We had 21 subacute individuals. There were 17 to 57 days post-stroke. 11 were in control group, and 10 patients received functional stimulation for that reminder. These are the two tests. So this is the first test. This is called function impedance measure. This is what we use to monitor how the patients are improving. And this is very coarse measure because it's looking at this patient, able to feed himself, bath himself, dress upper body, lower body, groom himself, or do toilet. So it's really testing activities of daily living. It's not testing the range of motion or the strength of muscle contraction, but what the patient is able to do in the daily living. So this is where they started. So this is the patient 1 to 11 in a control group. The minimum score is 6. So you can see there's 1, 2, 3, 4 people who actually have no function whatsoever. And this is a treatment group or intervention group, and they're very similar. This is where they start. The maximum score is 42, and this is how they ended up. So the median gain here is 8, and here is 22. So if you dislike statistics, there's another way of showing that. So here's the control group, this is a treatment group, and these are the patients in the control group before the therapy, and this is the patients in the treatment group before the therapy. This is after the therapy control group, and this is the treatment group after the therapy. I don't think it's difficult to decide which of the two groups you want to be. The next one, which is also important, this is an upper extremity Fugl-Meyer assessment. It's looking at the function of shoulder, elbow, forearm, wrist, and hand. This is the range from 0 to 66, and 6 points is considered clinically important difference. So if you get a 6-point change, then this is something that clinicians will say, oh, this is great. And now we're going somewhere, right? So here's the original data again. Control group, subject 1 to 11, treatment group 1 to 10. And you can see they're all below 15 points on Fugl-Meyer upper extremity scale, which means they're really low. And these are typically people with whom we have very little success if we try different therapy modalities, existing therapy. These are the outcomes. So this is a control group. And we have here one patient who had improved. This is typical. 1 in 10 tend to improve on their own very well. We don't know why, but that's what happens. And the rest, you can see what are the typical outcomes. And this is our population. So the median gains is here 0. Average is about 3 points, which is not clinically important difference. So, and you can see every single patient had a clinically meaningful difference achieved. So there's some patient videos. So just a reminder, that was the gentleman you saw at the beginning. I won't show you the same video. So he had no function, and this is him 40 sessions later. Everything is done by him. He does it himself. The cup is full with wax, so it simulates the weight, and you can see what he's able to do on himself. These are all elements part of the test, which is called Trump-Riga hand function test, that we use to assess patients. So these are not arbitrarily chosen elements. Anyway, so I want to show you a video which actually Trump-Riga has done a few years back. So that's his story.
This big 300-pound guy had the ball and it came running like straight at me. And it went horribly wrong. I immediately realized, well, I had a broken face because my jaw was over here.
It was so serious they didn't know whether Andrew would survive the knee stroke. We were fearful that we might never hear our son's voice again, or that he might not ever be able to walk again, or use his hand or arm.
If somebody has a high-level stroke injury, probability of improvement is less than 10%.
So basically with functional electrical stimulation, we are retraining function. One component of the signal goes to the muscle, but at the same time, we are also sending a signal to the brain of the movement that's being executed.
They were saying that it would train the muscle, and my brain would obviously connect that pathway.
Within months, we could see improvement.
Very encouraging, like we saw hope.
It did wonders for me. It pretty much gave me back my arm.
If it wasn't for the functional electrical stimulation, he wouldn't be what he is today.
It definitely has made a huge difference for him.
Trauma rehab and FES, it's been great for me. It's basically got me from dependent to being independent.
So Andrew did ask for this, so you can ask him what was his experience, and is this really genuine? So very briefly, conclusions essentially is that, there are a couple of elements to this therapy. We need a patient who is motivated and eager to participate in the process and understand why he's there, why she's participating in the process. Second, we need a therapist who's guiding and controlling and monitoring the process. This is not something you take home. And the third thing is you need the technology which allows you to do different sophisticated reaching, grasping tasks that you can coordinate with the patient. And we have this very nice outcomes which are unmatched by other technologies. So we're very proud of this. Now, one thing which Cindy asked me to tell you is about the journey. Okay, so that looks like very, very nice and easy, but the journey is certainly important. So this is the journey. Right? So it starts in 97, and then we're in 2014. So that's about 7 years. Anyway, so we spent about 4 or 5 years trying to figure out how to do this technology. So we built a box, we've seen it on the video, that we actually design a box that we can test all these different principles. When we built the box, we did not know which principles we could test. But we made the tool very competent and capable to apply different strategies. And that allowed us that as we realized what's working with patients, we can very fast and easy change those protocols. And in a matter of minutes, go from protocol A to B, C, F. So you open our program tool to see what we have done. There are lists and lists of protocols that we have designed and failed and tried and failed again. More failures than successes, but at the end of the day, you finally find out some of those which work very well. That's what we do. Then we try them in different patient populations, right? And then when we have this aha moment when we find out, oh, this actually really causes a plasticity in the brain. At that time, we did not know it was plasticity, but we're doing something profoundly to retraining the brain. That was a very important moment. And then we did all kinds of different pilot studies and another pilot study and a little bit bigger study. As we gain more confidence, the more we do, and then we did randomized control trials, which engineers typically don't do this type of thing. So when I started doing that, people thought I needed therapy. Michael Septon, when I started going to do randomized control trials, because this is a terrible decision on a 10-year track. What are you thinking, right? Anyway, we did it, so it was a good thing to do. And then in 2008, after we had this really nice results in both stroke and spinal patients, we went and created a company which is called Simple Systems. And we thought, now we have a company, we have a technology, and this is going to be going like that. Not really. So we struggled for quite some time, and we couldn't figure out how to break the sound barrier. And then, as we couldn't do that, then we did some more technology, because that's what we can do very well. So we built some more technology, and then in about 2011, Diana came on board, and it was a very interesting conversation in January, February of 2011. It was like, if you watch Kung Fu Panda, it was about one of those moments, when you think science, you're good. When you think business, you suck. So let me show you how we can do this together. And she was really transformational. We came in and, we resurrected the company, got some small funds and a little bit more funds to move this forward with a business plan. Toronto Rehab and UFT came forward and helped us with IP translation moving into the company. We got first private investment in 2012. We changed the name to MindTech because there were so many simple systems out there that were so we Google it's 15 pages. So we needed to have something which also speaks what we do. And then we created a product, which you will see today, and that we are working on to demonstrate this as well. And then we launched the product. We got a Health Canada approval in April 2014, and we launched the product in October this year at the National Spinal Injury Conference and American Conference for Rehabilitation Medicine. And we have, Alexa, 6 clinics.
Yes.
6 clinics for now. And Alexa tells me that they are fully booked at the moment. So one thing which is very important is, when you look at this journey, that looks all very nice, but there are critical moments in this journey where actually the only people that can help you is foundation. So what are the critical moments? You have a technology, you have this aha moment, but you need to test it somewhere. So we went actually to foundation, got initial funding to try this on spinal injury. If you would go to any granting agency, they will laugh at you. Where's your initial data, right? There's this kiss of death of every CHR or Hansen Institute kind of funding. It's all very nice. Show me preliminary data. I don't have preliminary data. So it was actually Toronto Rehab Foundation which came forward. Here's the funding for the therapists to carry out this thing. And that was the essential building block of the whole thing. I mean, we have the toy, but what can we do with this? And then we had another one which we said, okay, this is working great, this spinal cord injury patient. What about stroke patients? Again, it was Toronto Rehab Foundation and Physician Services Foundation came forward and together helped us to actually try preliminary data on that patient population. And finally, you know, when we have done all these nice things, then we needed to go to the next place, and we needed some additional technologies that are now in the device, make device not uncomfortable, which is typical for electrical stimulation. Electrical stimulation is typically very uncomfortable. We needed to solve that problem. Again, Toronto Foundation as part of the New came forward and helped us bridge that gap. So, in my opinion, all those critical moments, which took us from being, you know, having a potential to demonstrating something and demonstrating it very strongly, was actually supported by Toronto Foundation. We are extremely grateful to the foundation for being there for us on every critical step. So that's it for today for me. And if you want to find out what the company does, please go to their webpage, which is marketing.com, or you can find out what we do in my lab, because this is one of the biggest successes of my team, but we do all kind of other things like brain machine interfaces and cushions for pressure sore prevention. And also we have a little presentation illustration how the system works, and it's going to be done by Iris and Debbie, and Howard is going to tell you about the Rocket family upper cervical clinic that he helped us.
We met in 2001, just after we had the aha moment.
Yes.
So that we first and so it's a little ironic that we're standing here full circle of this technology. So I mentioned earlier that engineering and healthcare, and I truly believe that the great finds, great discoveries and treatments are actually come from people like Milos and Jeff Hardy, who was, I introduced you earlier, but you had to step out. Actually, just wave to people. This is Dr. Jeff Hardy. I'm also an engineer, amongst other things. But really, it's this kind of collision of these engineering problem-solving minds with healthcare professionals, whether they're occupational therapists, physiotherapists, physiatrists, which are rehabilitation doctors, kind of coming together to address the challenges and create solutions, design solutions, which is what my tech has done. We mentioned Howard Rocket. Howard is here this evening with his wife, Debbie, and talk about an enabler. So Milos mentions the foundation kind of stepping in at critical moments in time in the development of this technology and really helping deliver what's here today. The foundation really is a extraordinary philanthropy, donors that step forward and do great things. And in fact, Howard and Debbie stepped forward in a pretty profound way. About 18 months ago, decided to put significant resources behind the establishment of the Rocket Family Upper Extremity Clinic, which is just down the hall over there. If anyone wants to go journey after the session tonight, the lecture, you're welcome to do so. But it just opened up. We have Debbie Hubert, who is an occupational therapist, and is a lead, a project lead, and we have Irene Tunis, who's a physiotherapist, both working as people in this clinic, and thrilled that you two are here this evening. Howard Rocket was a stroke patient, or has been a stroke patient here at Toronto Rehab. It happened close to 20 years ago now. It was a sporting accident that led to a stroke. And he has stayed in touch with Toronto Rehab in many ways over the years since the incident. He has become an advocate of the work that we do. He's a motivational speaker. He comes and speaks to stroke patients and their families on a monthly basis. Inspiring is an understatement. He's an author. He wrote a book called The Stroke of Luck, with proceeds coming back to Toronto Rehab. He's a dentist, he's a businessman, he's an entrepreneur, and he's just an all-round great guy. So Howard, would you like to come up and say a couple words? Or? Okay, that's fine.
That's the reason.
For sure.
I guess it was probably a couple of years, well, 18 months. Cindy, I got a call from Cindy, and she said, we have all this money in the book. What do you want to do with it? And I said, I don't know, what do you want to do? So she said, well, they've got this therapy, functional electronic stimulation. I said, no, I've had that before, and it doesn't really work. And what I was telling Cindy was basically, what I tried was stuff that was just random. They put on some electrodes, and my hand just went all over. There was no function. Let's put it that way. So when Cindy and Mark Bailey explained to me what they were trying to do, not just with this, but with other therapies under the direction of Debbie and Irene, in the clinic, we decided that that's where we want to. I've seen so many stroke patients over the years, and one of the things, like this hand is paralyzed, but when you see what this hand is going to be able to do, thanks to Milos, Popovic, Debbie, and Irene, it's quite amazing. It's amazing to me that I've only had 6 sessions out of the 20 that we're going to be having over the next, I guess, 14 days altogether. Because I come in here, as Debbie and Irene know, every single day at 1:30 to get a therapy done. Because I'm really enthusiastic about what they're doing. But when I saw this, when Debbie asked me my expectations, I said my expectations are 0 and my hope is 100%. Because basically, after 19 years, and Milos will tell you this as well, well, you heard it already in the presentation, the closer to the event, the better the outcome's going to be. So mine's 19 years. So what did they really expect? What did I expect? My expectations were 0. Now, I'm going to ask Debbie and Irene when we're doing the demonstration. I want questions from you people, not so much to me, but to them. They're frontline people that have. Milos started this by saying he has conflicts all over the place. I have 0 conflicts. Unfortunately, I don't own any part of this. Debbie and Irene also don't own any part of this company. So what you're hearing tonight is totally transparent. And what I'm going to tell you is I'm very impressed with what I've seen. But I understand from Jeff that this is not the only thing that's being done here. It's many things that have made this place a world number 1 in research. Think about that in Toronto. I mean, we used to have Rob Ford to make us interesting. Well, we don't have that anymore. But now we've got the Toronto Rehab is number 1 in the world. That's pretty damn impressive. And I'm seeing it for the first. I'm seeing it as a patient. And that's where I was really interested. It's one thing for Mindtech to do well, and Mindtech is the company to do well. That's great. But my interest was patients. Because way after I'm not here, and all of us aren't here, patients are still going to be treated. So when I tell patients when I speak to them every month, I do it in this facility, I do it in other facilities as well, that there's a new therapy. And I don't tell them what it is yet because we don't know. There's been some initial great successes. And I didn't know myself. I had to try it myself to see what it was actually like. And every time I finished here, I call my wife right away and say, you're not going to believe what I can do today. And again, under the direction of Debbie and Irene, I've done it with the machine, which you're going to see. Because there's nothing more dramatic than actually seeing what actually happens. It certainly was for me, especially when they turned it on. I've always been asked, how does it feel? Well, the first time that Milos did it on me, I had to take off my shirt. Debbie was, I'm sorry, but Alexa's mother was there, Deanne, who was the CEO of the company. I had to take off my shirt because my arm had to be exposed. Well, today, we sort of did it, and I said to Debbie, it's sort of like a cooking show. We prepared everything before. So all my electrodes are on already, so you don't have to go through all of that. You're going to see, basically, through this demonstration of what this technology can do on somebody. Now remember, 19 years, I haven't done anything with this hand. It's just been lying here for 19 years. This hand does everything. Thank God, God made us with 2 of everything, so that this hand can actually physically do things. I think my challenge will be, once this hand starts to really, really progress, I'm going to have to reteach this hand not to do everything. And that's, I know it sounds a little bit humorous, but it's true. That's going to be something that we have to do. I was talking to Jeff today, maybe my next step will be restraint therapy. To restrain this hand from not doing it, so this hand can really start to take over the function of what it should be doing. To tell you the truth, I forgot what this hand actually does, because this hand does so much. I couldn't tie my shoelaces. At the Toronto Rehab on Runzie, And one of the places Toronto Rehab has, they actually taught me how to tie my shoelaces with one hand. So I'm not even sure I could use two hands to tie my shoelaces. But I don't know, and I'm going to have to teach this hand to just relax. Let this hand do some work. So if you like, let's sort of do the demonstration. I'll get my wife to help me take off this. I didn't want to come here in a t-shirt. But it's freezing cold. Now, if you have questions, I think you want somebody to interact, just belch them up. Yes?
Bioness. Did you ever try the Bioness technique?
No, I haven't. I got the information on Bioness. I was going to try it. By the way, I don't normally dress them. I haven't tried it. I know people that have tried it. It's very good for a while, and then they lost. What I like about this is it's going to teach my brain to do it on its own. So eventually I'm not, I obviously can't be hooked up and walking around. So the Bioness is, in fact, I spoke to a lady today who had a stroke. She's 45 years old. Her stroke was about 3 years ago, 3 or 4 years ago. And it really worked very well on her.
At the beginning?
At the beginning. And then she got disappointed. So even this, she's a little skeptical about it. And I don't blame her.
And the electrical shocks, does it steady the shocks? The Bioness gave you electrical shocks all the time.
Well, I don't know about the Bioness because I've never tried it.
But does this one?
What this thing feels like is if all of you, your arms fell asleep, that's what it feels like. Like that kind of sensation when your arm is asleep. But it doesn't hurt. The first time that Milos did it on me in his clinic, I guess generation, I don't even know what generation, this must be 3 or 4 generations past. It really was uncomfortable. It didn't hurt, but it was uncomfortable. They needed so much electrical output into these electrodes, or into these sensors, that it actually was uncomfortable. Now, this machine has, I don't know, Milos, how much, where are you, Milos?
Sure.
Okay, how much power goes in this versus what you showed me when we were living?
10 times less.
10 times less amount to get the muscle to do what it has to do. Now, I really have to thank these two ladies here, because I must tell you, when I walked in the first day and tried the therapy, notwithstanding what Cindy told me, I was very skeptical. Nothing would happen, especially after 19 years. So what you're going to see is, and again, I have no other reason to tell you this other than I'm fairly excited about it because it hasn't worked for 19 years. Okay, so let's get started.
So can you hear me okay? I'm just going to tell you what we've done in preparation and what we're doing now. And Irene's going to, can everyone see? I don't think everyone can see.
Debbie and Irene, yeah, just come on up.
Yeah, come on, it's fine.
Because you're going to want to see this. Come on up.
I will move this out of the way once we get it back. So we can pull chairs around too.
I've been watching it from a patient's point of view and a business point of view. I want to know, how does this damn thing work? Why is this happening?
Okay, so what you'll see is we have put electrodes on Howard's arm in various places that will stimulate certain muscles. And what he's trying to work on in this first movement, so there's pre-programmed movements. And the first movement that he's working on is side reach. So one of the things that you have to know is when Howard first came in to be tested, we'd say, can you reach your arm up? And he'd say, this is it. And it wasn't very, very much. And then...
Where's my Fugelmeyer? Who is Fugelmeyer anyway? What was my score? Can you tell me?
Your score, I'm trying to remember. It must be over 19, so I think it was probably around 14, I think.
Doing very good.
Yeah. So anyway, so he could do very little with this arm. So we thought, okay, we'll start with the reach protocol and see what happens. And so right now, this reach protocol has 3 sets of electrodes on. The electrodes go on the biceps, they go on the triceps, and then the middle deltoid. Now, what's very cool about this is when you can, and you saw some shots that Milos showed you, but when you go in and start to set up the electrodes, it actually shows you where to put them, and it gives you
a great description of where you should start to put them. Now that isn't a fail-proof system. You actually have to go and play around a little bit to get the response you want. And that's what we did ahead of time. We played around with it a little bit. We played around with the response we wanted. And so now we're going to show you a little bit about what this looks like in terms of treatment. So what we can see here is on our screen, okay, so we're going to have to start creating the lines. I want the pre-program. It's the pre-program. Okay, so basically, what we'll do right now is I'm going to actually support your arm a little bit just to start with.
Now this supporting is literally just supporting and guiding. The movement is me, or well, the machine and me. Because it gets cold.
Yeah. Okay. So what I'm going to ask him to do is I'm actually just going to turn the machine on and show you what the machine can do to start with, and then we're going to connect it with what he can do and amplify his movements. So the first thing we're going to do is we're going to get you to bend your elbow up like this, okay? Okay. Well, that's the machine. And now we're going to get you to bring your arm out like this, chicken dance style, okay? And now we're going to get you to straighten your elbow. And now we'll just get you to relax. Oops, flexion first. And now we're going to get you to relax.
Now that is probably 90% machine,
Okay.
maybe 95%.
So now we'll start and we'll ask you to.
I realize this arm did nothing, no movement whatsoever.
So now I would like you to start to flex your elbow. Okay? And I'm going to now help you a little bit more. So you see the machine just takes them that little bit farther and amplifies that. Now I'm going to ask you to do the chicken dance move out to the side here. And go ahead and start. Okay. Now, the next thing I'm going to ask you to do is I'm going to ask you to straighten out your elbow. Start doing that. Okay. Help you go all the way down. Okay. And the next thing we're going to do is get you to flex your elbow. And the next thing we're going to ask you to do is just to relax your elbow.
Yes. And you'll see we're going to try this with just music at the end because it's already starting to teach the brain a little bit. It's not, I mean, we're only through 6 sessions of potential 40 and developing new neural pathways to allow this to happen. It's quite amusing.
So the next thing we're going to do,
Did I say anything wrong?
you didn't say anything. So the next thing we're going to do is we're going to actually get, because we're therapists, we're going to be a little fussy about how we're starting the movement. So we're going to get him to bring his leg back so he supports it under here, and he's going to sit tall. And Irene might just be behind him here.
Pushing.
Not pushing, just making sure that he doesn't do too many extra things with his trunk to get the movement, basically. Okay. So, you're okay?
Yep.
And he's working on that core movement too while he's doing this. So we're going to get you to flex your elbow. And now we're going to get you to bring your arm out to the side. Okay. Stay forward, good. And now we're going to get you to extend your elbow. Good, nice. And now we're going to get you to flex your elbow again. And now we're going to get you to bring both of those together, extend your elbow and bring your arm out to the side. Good. Okay. And now we're going to get you to touch the leg and relax. So we're combining this with a little bit of making sure that he's staying in a good posture, and that works his core a little bit differently. He was used to doing a lot of movements like this to get his arms to do that kind of thing. So, okay.
So I'm reteaching the core. Don't do it. There. Not me.
So we'll repeat this a couple times, and then we'll get Howard to just try it on his own. Okay? All right, so again, we're going to go.
By the way, that phone call with my arm saying, get ready.
Okay, so the first thing is we're going to get your arm to flex. And now up to the side. And now extend your elbow. Nice. Okay. We're getting tired here. Okay. And flex your elbow again.
This is 2 sessions in one day.
Okay, and extend your elbow and bring your arm out again. Okay. And now just relax.
It's important to visualize what she's saying. Like, I got to know what Debbie expects me to do. So, because if I don't know what they expect me to do, the machine is doing it. Now the machine is only doing a little tiny bit. I'm doing most of the work. And she's guiding me. She's holding. So other than that, as long as I got these 2 people with me, I'm in pretty good shape.
Okay, so let's just try some of those movements on your own now before you get too tired. Are you?
Yeah, no, I'm fine.
Okay, so bring your arm up into flexion. Okay, and you see he's abducting. Can you extend your elbow? I'm going to just hold it at the end.
Just hold it so it's
Yeah. Okay, and bend your elbow again, and now straighten to your lap and relax.
and that's just me.
That's it.
Wow.
That's bad, not me.
No, that's for you. He's very good at doing his homework every day. He gets home and practice it very well. So now I'm going to re-hook him up into another configuration for his hand. And
The reason we're going to do this part is it's fairly dramatic. It was certainly dramatic to me to get the hand to sort of open, because it hadn't done that in years. I can somewhat close it, but not great.
You can, I can grip it, but
Yeah.
you can
That,
ungrip
and
it.
but that's typical for stroke. So you'll watch what you can do.
May I ask a question?
Yes,
Because a lot of this is muscles that haven't moved or worked in 20
I'm going to
years.
sleep for a long time.
So is the time it's taking actually building back up muscle mass? Like there's pathways that are already forming in the brain, I'm assuming, right?
That's
These
correct.
pathways?
so what we think we're actually seeing a little bit with Howard is that there's something called learned non-use. So he's not been using this hand because it hasn't been being used very effectively to do things. So he does everything with the other hand. And the other thing you have to know is that he's actually maintained his muscles in a very healthy condition by working out and taking fitness courses and so forth. So we're working with somebody that's already got a sort of healthy muscle to work with. And some of the reasons why we're seeing some good responses very quickly is we think that we're just reminding him what he can actually do with that hand. So once he gets a couple ideas or a couple repetitions, and that's why it's taken very few sessions actually to get some responses, he actually remembers how to do it. So that connection, that brain muscle connection has come back, and so he's actually able to just use that and try to open it and try to do it. Now, something that sometimes happens is if he does it too many times, he gets fatigued and then he starts to get tight again. And so we have to make sure that we relax and then go through the process again and then start it up again and then have him do that. So, good? Okay.
Does that answer your question?
Just for a second. What is good with stroke patients, they usually have tone. So they usually maintain their muscle.
Why is that?
Because both extensor and flexors are firing at the same time. The problems that you mentioned is more common in spinal cord injury patients.
Okay.
They don't have it. And then we need to strengthen their muscles, and we do that. So it's a part of we have a protocol that helps build the muscle. With stroke patients, that's not usually the problem. But but the spinal cord.
And so once that neural pathway is reset, presumably the smoothness of the functionality you're going to get back in your left arm will only keep improving, correct?
I would say that's
Continue to strengthen it.
yeah, you got to strengthen the muscle, and that will. You're right.
Holy smokes.
As the muscle gets stronger,
The
it'll
smoothness.
be much,
yeah.
much more smooth.
Okay.
Is part of what the electrical stimulation is doing is telling you said that both the contractors and the openers fire at the same time. So is part of what you're doing teaching some of them not to
To
open?
let go.
Okay.
Yeah. Okay. So,
By the way, my wife has seen this for the first time too.
okay. So, what we're going to do now is we're going to get him to extend his fingers and then attempt a pinch and then relax his fingers. So, the first thing we're going to do is we're going to get you to extend your fingers. Okay. And now we're going to try for a pinch. 5. And now we're going to get you to open your fingers and relax your hand.
Now what happens is these fingers have little tiny muscles, so they get fatigued fairly quickly. We had pretty good success with this. Now you also have to understand this is the first time in 19 years that the hand opened. That was 2 days ago.
Okay, so we'll open your hand again. Come up there. Okay, and now we'll get you to touch your fingers. Okay. Just overshooting a little bit, so let's just take this down a little bit.
So what Debbie is doing is just decreasing the intensity to some of the muscles. So if you notice, if we're thinking about the pinch, you're thinking about that movement, and his thumb is coming, down faster than his index finger, right? So we can either decrease the intensity, or we can actually help as therapists to actually guide that movement, so then it's accurate. So we can try both ways, and Debbie is trying decreasing the intensity and retrying the movement.
So let's go again. And then it's going to relax. Okay, so now we're going to try and open your hand again. Get this thumb to come up here.
That's it.
There we go.
So basically, as a therapist, you can also help guide that. In this case, if you want to really coordinate or smooth that movement.
All right, and now we'll go for a pinch. And now we'll open your hand again. And we'll just relax.
So these muscles get pretty tired pretty quickly. Now I don't feel it, but I asked Debbie and Irene exactly why it happens that way. It's because they're tiny little muscles.
Just going to relax for a sec. We need a warm sweater on you, too.
The other thing is when your hand gets cold, this hand tends to close.
So, Howard, just out of interest, can you try and open your hand right now? Just give it a try. Not quite at the moment, okay?
So there's a lot of factors to this. If my hand's too cold, which it is right now when the room is a little cool, because I did the other day, I actually initiated opening the hand on my own without the machine.
Yes, I was telling him to think about doing the movement, and he did the whole movement. So I was like, oh, wow, that was like a little bit. So
That's a lot
that's great.
warmer in that room.
A lot warmer. Okay, so let's try again. I've just moved the electrode just a little bit, so maybe we're gonna. Okay, and we're going to open your hand. Okay, so let's take that down.
By the way, that does not hurt. It just doesn't look great.
So what does it feel like? Just
Pins and needles. What's that? Doesn't really hurt. It's just, you know, when this hand goes up a little, like I can actually move the wrist up a little tiny bit, and then the fingers will start to open up. But when they turn on the machine, it's just like no more. Even if they turn it right up to the maximum, it's still not uncomfortable. It's just a lot of pins and needles there. It just doesn't seem to go away.
So let's try it again. So I'll open your hand up, and you think about opening your hand now. Too much? No, I think it's because you're puzzled. Okay. Okay, and now we'll take a pinch. This is Howard, not me. And now open your hand up.
You see that I'm doing with this hand as well? Because my brain is visualizing. This is helping my brain visualize what it's supposed to do.
We're giving him some tricks to get that imagery a little bit stronger while he's doing this.
So what we also do between sessions a lot of the times is the stretch. So very similar to, you know, some of the exercises you've been given in the past is integrate that during our session as much as possible. Just to, again, relax the muscles that have been overworked or are starting to get fatigued and see if we can actually continue with the session.
Second here. Got your sweater on? Yeah, my hands are pretty cumbersome.
Sorry, have you tried combining this with mirrors? We have not. So this is
No, but one of the things we were talking about, and Milos is the idea there, is putting something on the actual screen, the iPad here, what it is they want me to do, or an actual camera showing me what to do. Like just a little corner. We don't need the whole iPad. Something to that effect. So there's some visualization that comes into it.
All right. You're ready to go for one more try? Okay, so I want you to think about opening your hand. And we'll get you to touch your. There we go. Nice pinch.
It's this one we're trying to do.
Yeah.
I'm thinking about it. I'm really thinking about it.
And now open up. And we're just going to relax.
Okay, so one of the things I'm sure is the wrist.
Okay.
But I got to take this stuff off when we're done.
Yep.
Now, before my wrist wouldn't move at all. This wrist just did nothing. Now, I'm not going to show you going like this, but you're going to see some. This will be all me because we're going to take all this stuff off. Yeah, go ahead. This doesn't hurt much.
Those electrodes, they're reusable?
So they're not.
Oh, was it one single use?
Yeah, that was Milos' idea, so he's got Okay, so this hand, boy, it's got to calm down again. It gets cold.
Yeah. It's cold. I think that this is.
Okay, so this hand did absolutely nothing. That's just me. We worked on that about 3 days ago. And it'll get stronger as I keep, because I get homework. Of course, she gives me homework. But I failed the field tomorrow test, so that's why I get homework. So that should get better. Let's see how far I can That's it. It's getting tired.
Yeah. So, yeah, this is your second treatment session for the day.
We've done a session this afternoon at 1:30. Any questions?
Any other questions?
How comparable is the sensation to like a TENS machine?
To a what?
To like the TENS machine, so the electrostimulation.
So compared to before. The question?
How similar is the sensation to a TENS machine? Maybe the physiotherapist can explain what a TENS machine is.
Yeah, so before your previous experience with functional electrical stim, how is this in terms of the delivery of the current different?
The current, I think Milos said it's 10 times better than that. But originally, this hand, when I put on the, and I didn't know what I was doing, I just put on the
Electrodes.
electrodes. When I put on the electrodes, the hand just went all over the place. So there was no function to it. That's what the beauty of this is. There's a fun. I'm actually trying to do things with this arm that I haven't done, like opening up a door. I may have to put my hand on but I can actually start to turn it and pull. Not my body pulling, but my arm actually pulling. It's just adapting some of the homework they give me to everyday life, because if all I can do is do this in front of a whole bunch of people, it doesn't do anything, unless we charge it a minute, fee to see. But if I can do it for what I need to do for everyday life, living, that's the whole idea behind this.
So I just wanted to talk to you a little bit about how much stim we put in. So what we do is when we apply the electrode, the person actually controls how much stim goes in. So we say, "Are you okay? Are you okay? Are you okay?" And we have a method. He taps and he says that's enough. So, and then what I'm looking for is just the start of the movement, and that's when we stop. So that's and you know. I get the sensation of it, but yeah.
It's really, it's not uncomfortable at all. Not at all, really. I thought it would be. The first time it was not fantastic. That was his problem. And then he came up with this, and it's way better.
And to add to that, some of the patients that we've had in the trial that are susceptible to pain, and we know that because we were treating them before, they actually are not reporting pain, which we find it surprising because, you know, other functional electrical stims, a lot of times that is a concern.
This is upper extremities. And I think the presentation was mostly about upper extremities, but presumably,
and I said that to Jeff earlier. Like, why can't we do it for my leg? Why can't we do it for drop foot? I think you can do it for anything that has muscle. There are other, like how do they apply that? How do they keep me steady so I don't fall over if I lift one leg up? Well, they'll figure that out. But yes, your answer to your question is this thing is adaptable. I would consider the upper extremity a product, and then the next one will be the leg, and then it'll be my drop foot, and then it can go on to unbelievable.
Well, I was just going to say that it has applications right across the spectrum, not even people with really severe issues, but isn't this technology that's going to disrupt existing therapies?
That's good.
Absolutely.
We
needed the product number one. Once that takes rings,
this is product
number 2 and 3 are in a pipeline.
But this is like a blockbuster.
That's it. Oh yeah.
This is a blockbuster.
Well, when I saw
that's the intent.
When I saw it, I said it's a game changer for stroke. Realize I'm doing it as a stroke patient, so I want to see how does it work. Does it work on somebody that's that far out? And what are the other applications that I'm looking at this thing as? See, I'm a stroke patient, but I'm also a business person, so I'm looking at it from both aspects. I think this could be a game changer, and it's developed at the #1 place in the world. That's what's incredible.
I have a question I'm going to ask myself. Actually, I'm kind of the kind of MC, so I guess I'm asking myself.
You can ask me.
It's actually directed at Jeff Fernie, and I'm hoping, Jeff, that Dr. Fernie can just make a couple of remarks on kind of the collision between research and clinical care, and what really makes part of what makes Toronto Rehab so very special.
Yeah, I will. That is going to be the key to its success. It would not be possible to develop these technologies in isolation in an engineering laboratory. It just wouldn't happen. And that's not just this technology, it's all across the organization. We have 11 teams, and they're all working at the interface between science and clinical care. So what we've done so far is pioneering. Research now, this hospital is now the #1 rehabilitation research center in the world. At the end of the week, we're starting to talk about our strategic plan for the next 5 years. And the theme I'm pushing is that we want to be the #1 rehabilitation research and treatment center in the world. And to do that, you have to forget about just doing what used to be called best practices. Everyone has to do best practices. That's mediocrity. You've got to do stuff that no one else is doing. So we're going to be doing stuff that no one else is doing. And we've now got to the point where several of the technologies have been developed far enough to start working with our nurses and our therapists and our physicians together and with our patients to make that happen, to do things that no one else has ever done. And it's really, really at the cusp of some very exciting stuff.
Did you want to mention some of that technology that you've been developing? Just a couple of things.
I don't want to take away.
Oh, you know, we'll invite everyone back again.
Today, but there's everything going on here. Everything from someone who's having trouble swallowing. You know, no one really remembers these people. You know, the word is dysphagia. And you have people who have trouble swallowing, and you've seen them die. You've seen many elderly people, I'm sure you have, who wither away, who struggle, and they can't take the food in the end, and in the end they get fed up with the mushy food, and they give up eating, and they go away. There's also people who can't swallow properly, and they breathe in their food. 40,000 of them a year in Ontario, and they get pneumonia, aspiration pneumonia. So this is just one condition. We will, by the end of 2017, have an instrument here that you can just put against the neck of someone, and it will tell you whether they are at risk of aspiration. And moreover, it will tell you some other things about how to select the foods for them. It's totally a game changer. We've done the same with sleep apnea. 1 in 10 people has sleep apnea. In fact, it may be higher than that. As many as 1 in 5 it's thought of. But 1 in 10 is a safe number, has sleep apnea. That's a lot of people. And those people who have sleep apnea, why are we concerned? Well, if they have sleep apnea and we don't treat them, they have 4 times the chance of having a stroke like that. They have 4 times the chance of a heart attack, and they have twice the chance of causing a major train or car or plane accident. It's a huge problem. But only 1 in 10 of those people know they've got it. Because you have to go to a clinic and have wires and things stuck up your nose. It's awful, and it costs a lot of money. We now have a game changer, another game changer, which is the next company that's coming along. Would you just take this thing home and wear it at night? And it does the diagnosis as good as a hospital sleep laboratory, right? And you can throw it away afterwards if you want. And everything down to we're worried about this winter, right? We had icy steps, worse than we've had last year. We had 5 times as many people in our emergency rooms last year as we on an icy cold day as ever. We all know people who fell over. Some of those people died as a consequence by now, because if you break your hip, that happens. Many of them lost their independence forever, their independence, mobility forever. We're facing that again this winter. In Quebec, we put snow tires on. If not, we get fined. We don't pay attention to our footwear. It seems pretty elementary that we should have the right footwear for the winter. So we've invented the first understandable test to determine how good footwear is. And the footwear companies, you will start to see, not for this winter, but for next winter, you'll start to see labels that show you in an easily understood way how that footwear will perform. We're also developing very advanced footwear, which will really blow your mind in terms of being able to move around safely in the winter. So there's everything. There's stuff that goes from how you get on and off a toilet, how you get in and out of a bath, how you move around your home, how you get diagnosed for problems, how you get treated for problems. This year we've changed the building code for stairs in Canada. Huge breakthrough. That one change in the building code the National Research Council has told us will result in 39 fewer deaths and 13,000 fewer serious injuries in the first 5 years of implementation. So you calculate the return on investment on some of the research that's going on here, and it's huge, absolutely huge. And the question that Cindy asked is, again, is it going to work? And the answer is yes, it's going to work because of people like Debbie and Irene, right? It takes me a long time to get names right. It's going to work because everyone's coming together and getting excited about the place as a team. And you will see, and Cindy will see on Friday and on Monday, we've actually illustrated this hospital with an enormous poster all over the front of it, like Princess Margaret. And I don't want you to whisper this to anyone. Princess Margaret has a poster which says one of the top 5 cancer research centers in the world. Ours says top rehabilitation research. And it will soon be able to drop the word research, and in the next 5 years it will be the full stop, the top rehabilitation center in the world. That's the end. It'll be that team.
Bravo.